Hi everyone, this is lesson 11-4 on page 772, and we are going to be looking at inscribed angles, which are pretty cool. This is similar to our central angles that we studied, but I'll show you how they're different. An inscribed angle is an angle whose vertex is on a circle instead of at the center of the circle. It's on the circle, and whose sides contain chords of the circle. Let's stop there and look at our picture. An inscribed angle is an angle whose vertex is on the circle. Remember, the central angles were the vertex was on the center of the circle. So this is on the circle, the vertex is, and the sides of the angle are chords of the circle. All right, I'm going to try turning my phone to see if we can get this in without me having to move it constantly. There we go. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points on the circle in between them. So the inscribed arc is what's created by the angle. It's the arc that's created by the angle. And a chord or arc subtends an angle if its endpoints lie on the sides of the angle. So this arc subtends this angle because the endpoints of this arc lie on the sides of the angle. So let's review. Angle DEF is an inscribed angle. That means its vertex is on the circle and the sides of the angle are chords in the circle. Okay, the next thing is arc DF is the intercepted arc that's created by this angle. And chord DF subtends angle DEF. That means that its endpoints lie on the sides of the angle. Okay, let's jump down here to our theorem. The measure of an inscribed angle is half the measure of its intercepted arc. Let's think back to our central angle. Our central angle measured the exact same as the arc. So that means if I redrew this, I'm drawing a new angle now. And it's angle AXC. That was a central angle, and whatever the measure of that angle was, it was also the measure of that arc. All right, now let me erase that, and let's look at the inscribed angle and how it differs. The inscribed angle, instead of being the same, is going to be 1/2 of whatever the measure of the arc is. So if the arc were, let's see, I'm guessing this one might be about 85 degrees. If it were 85 degrees, angle B would be half of 85 degrees. Or let's say it was 80 degrees. Angle B would be half of 80 degrees or 40 degrees. All right, let's look at this one. It's a little bit different. Neither of its sides go through the center of the circle, but that doesn't matter. The inscribed angle with its vertex on the circle is 1/2 the measure of the arc. So let's say this arc was 60 degrees. The inscribed angle would be half of it, which is 30. And same here. If the arc measured 30 degrees, angle B, the inscribed angle, would measure half of 30, which is 15. All right, let's jump down. Actually, this is a proof. We're going to skip this proof and jump to the next page to example 1. So we are now, I'm sorry I'm jumping around so much, and I'm going to turn the phone on you. Okay, we are now at the top of page 773, example 1. Finding measures of arcs and inscribed angles. The first thing they want us to do is find the measure of angle RST. So let's come over here and look at our diagram. We need to find the measure of angle RST. So this is what we're looking for. All right, so we have to start deciphering information or deciphering the information that we're given. If you will notice, I know there's a lot to take in here, but if you will notice, angle RST is an inscribed angle of arc RT. That means it's 1/2 of RT or 60 degrees. Mathematically, we can write that formula as being angle RST, or the inscribed angle is 1/2 of the arc, or 1/2 of 120 is 60 degrees. All right, let's look at the next one. The next one is find the measure of arc SU. All we're doing here is going backwards. We're now looking for this arc right here, arc SU. And so we need to look at what its angle measure is. If you notice, here's the inscribed angle that goes with that intercepted arc, and the measure of this angle is 40. Since this angle is half of this arc, then this arc is going to be 2 times 40, or 80. And I could have written that 2 ways as a formula. I repeated what we had done up top. I said the measure of angle SRU is equal to 1/2 of arc SU. And then I said 40 degrees is equal to half of arc SU. Then I multiplied both sides by the 2 to get rid of this fraction. And arc SU is equal to 80. We also could have simply said arc SU equals 2 times angle SRU. And that would have given us the same answer. All right, let's look at our check it out. 1A and B, these should be pretty quick. The first thing we want to do is find the measure of angle, sorry, that's not an angle, of arc ADC. Here is arc ADC. I've kind of traced outside of it for you so that you see it clearly. It begins at point A, but it ends right here at point C. And then it took me a little while for my brain to be able to see this clearly, but then they created the angle, the inscribed angle that goes with that arc. Its lines are chords that are super close to the edge of the circle, so it's a little hard to see, but this is the angle, angle B, that goes with arc ADC. Remember, that's a major arc, so it has to be named with 3 points. All right, we know that the angle is 135 degrees, so we know that the arc is going to be twice that, which is 270 degrees. And moving on to angle DAE, let's see, where's DAE? DAE, so we're looking for this angle right here, and it's going to be half of its inscribed arc. If its arc is 76 degrees, half of it is 38 degrees. Okay, let me reevaluate really quickly and see if I want to stop this video and start a new one, or nope, I'm going to go a little bit further. Okay, so now we're going to move on to corollary 11-4-2, and that says if inscribed angles of a circle intercept the same arc, that means they share the same arc, then the angles are congruent. Now obviously I left out a little bit of the detail in there, but what it's saying is inscribed angles that intercept the same arc are equal. Let's look at what that means. We have 3 inscribed angles here. We have the red one, we have the blue one, and we have this green one. Please notice that all 3 of them share arc AB. That means that all of them are going to be exactly half of the measure of arc AB. So they are also going to be congruent because they are the same. So if arc AB is 40, then angle C is going to be 20, angle D is going to be 20, angle E is going to be 20. All right, let's look at the application of that. We are going to use this picture, which I have redrawn over here, to find the measure of angle DEC if arc AD equals 86. So we are going to find the measure of angle DEC, which is this angle right here. So let's look at it in my book where I've redrawn it. Find the measure of DEC, and are given, or there were several actually, the things that were included in the diagram telling us that this arc was 86 degrees, that this angle was 60 degrees, and then they also told us in the problem that arc AD, oh, that was the same information, that AD was 86 degrees. Okay, we need to start just working the puzzle pieces here. Angles B and C are congruent. Let's look at that. Why did I say that? Look at angle ABD and ACD. Do you notice that they share the same arc, which is 86 degrees? That means that they're each going to be 43 degrees and that they are congruent. So I said they're congruent because they intercept or create the same arc. All right, now let's look at what their measure is. We already did that. Half of 86 is 43. Now we need to solve for AEB, and then we can solve for DEC, which is our final step. AEB, we know that all of these angles add up to 180, so we know 180 minus 60 minus 43 is equal to 77 degrees. And if you will notice, these are vertical angles, so they are congruent, so DEC also equals 77 degrees. All right, I'm going to stop this video there and start up with a second one right after this.